हॅलो स्टुडंट्स, तुम्हा सर्वांचं स्वागत आहे माझ्या यूट्यूब चॅनलवरती आणि मी तुमची खुशी मॅम. आज तुम्हाला इयत्ता 10वीतील सायन्समधील पार्ट 1 चॅप्टर नंबर 1 ग्रॅव्हिटेशन या धड्याच्या स्वाध्यायावरील उत्तरे घेऊन आलेली आहे. क्वेश्चन 1. स्टडी द एंट्रीज इन द फॉलोविंग टेबल अँड रिराईट देम पुटिंग द कनेक्टेड items in a single row. Answer: mass kg, measure of inertia, weight Newton, n depends on height, acceleration due to gravity meter per second square, 0 at the center of the earth, gravitational constant Newton meter per square kg square, same in the entire universe. Question number 2. Answer the following questions. Question number 2. Answer the following questions. A. What is the difference between mass and weight of an object? Will the mass and weight of an object on the earth be same as their values on Mars? Why? Answer. Difference between mass and weight. Mass, weight. Mass is the amount of matter present in an object. Weight is the gravitational force acting on an object. SI unit kilogram kg, SI unit Newton n. Mass remains the same everywhere. Weight changes from place to place depending on gravity. It is measured using a beam balance. It is measured using a spring balance. Will the mass and weight of an object be the same on Earth and Mars? Why? Mass, no change. The mass of an object remains the same on Earth and Mars because the amount of matter in the object does not change. Weight, it changes. The weight of an object on the Mars is less than on Earth because the gravitational force on Mars is weaker than the gravitational force on Earth. Therefore, the mass remains the same but the weight decreases on Mars due to its lower gravitational acceleration. B. What are free fall, acceleration due to gravity, escape velocity, centripetal force? Answer. Free fall. A body is said to be in a free fall when it falls toward the earth under the influence of gravity alone without any other force such as air resistance acting on it. Acceleration due to gravity G. The acceleration produced in a freely falling object due to the earth's gravitational force is called acceleration due to gravity. Its value near the Earth's surface is approximately 9.8 meter per second square, directed towards the center of the Earth. Escape velocity. The minimum velocity required by an object to escape the Earth's gravitational pull without any further propulsion is called escape velocity. Its value for the Earth is approximately 11.2 km per second. Centripetal force. The force acting on an object moving in a circular path and directed towards the center of the circle is called a centripetal force. This force keeps the object moving in circular path. Fc is equal to mv square upon r. C. Write the 3 laws given by Kepler. How did they help Newtons to arrive at the inverse square law of gravity? Answer. Kepler's 3 law of planetary motion. First, law of orbits. Every planet moves around the sun in an elliptical orbit with the sun at one focus of the ellipse. Second, law of areas. The line joining a planet and the sun swaps out equal areas in equal intervals of time. Third, law of periods. The square of the time period t square of a planet is directly proportional to the cube of the semi-major axis r cube of its orbit. T square directly proportional to the r cube. How did these laws help Newton to arrive at the inverse square law of gravitation? By studying Kepler's law, especially the third law, Newton concluded that the force of responsible for keeping the planets in their orbit is the gravitational force exerted by the sun. He found that this force decreases with the square of the distance between the two bodies. Thus, Newton proposed the inverse square of gravitation, which states that the gravitational force between two objects is inversely proportional to the square of the distance between them. Therefore, Kepler's law provided the experimental basis that helped Newton's formulate the universal law of gravitation. D. A stone thrown vertically upward with initial velocity u reaches a height h before coming down. Show that the time taken to go up is same as time taken to come down. Answer. Let initial velocity u, maximum height h, acceleration due to gravity g. Time taken to go up. At the highest point, the final velocity v equals to 0. Using the equation v equals u minus gt, 0 is equal to u minus gt. So, t equals to u upon g. Therefore, time taken to go up, u upon g. Time taken to come down. The stone started from rest at the highest point u equals to 0 and falls through a height h. Using the equation h is equal to 1 upon 2 gt square. Also from the equation of motion u square upon 2gh. Substituting h equals to u square upon 2g into the equation. U square upon 2g equals to 1 upon 2 gt square. U square equals to g square t square. So t equals to u upon g. Therefore, time taken to come down equals to u upon g. E. If the value of g suddenly becomes twice its value, it will become 2 times more difficult to pull a heavy object along the floor. Why? Answer. The frictional force acting on an object is given by F equals to u upon n, where F is frictional force, u is coefficient of friction, n normal reaction. The normal reaction is equal to the weight of the object. N equals to mg. If the value of g becomes twice, then the weight of mg also becomes twice. Therefore, the normal reaction n doubles. As a result, the frictional force also becomes twice because F equals to u upon n. Hence, twice the force will be required to overcome friction and pull the heavy object along the floor. Therefore, if the value of g becomes twice, it becomes 2 times more difficult to pull a heavy object along the floor because of the object's weight and the frictional force both becomes twice. Question 3. Explain why the value of g is 0 at the center of the earth. Answer. At the center of the earth, the gravitational pull of the earth's mass acts equally in all directions. These gravitational forces are equal in magnitude and opposite in direction, so they cancel each other. As a result, the net gravitational force becomes 0 since the acceleration due to gravity g depends on the gravitational force acting on an object. If the value at the center of the earth is 0, therefore g equals 0 at the center of the earth because the gravitational pulls from all directions balance each other completely. Question 4. Let the period of revolution of a planet at a distance r from a star be t. Prove that if it was at a distance of 2r from the stars, its period of revolution will be square 8 t. Answer. According to the Kepler's third law, t square is directly proportional to r cube. Let the initial distance of the planet from the star be r and its time period be t. If the new distance is 2r and the new time period is t, then t1 square upon t square equals 2r cube upon r cube. t1 square upon t square is equal to 8. Taking the square root on both sides, t1 upon t equals to in root 8. So t1 equals to in root 8 t. Hence proved t1 equals to 8 in root t. Therefore, if the distance of the planet from the star becomes 2r, its period of revolution becomes in root 8t. Question 5. Solve the following examples. A. An object takes 5 seconds to reach the ground from a height of 5 meter on a planet. What is the value of g on the planet? Answer given. U equals to 0 meter per second. S equals to 5 meter. T equals to 5 second. G is what? S equals to 1 upon 2 gt square. So 5 meter equals to 1 upon 2 g 5 seconds square. 1 upon 2 g into 5 seconds into 5 seconds. G equals to 2 upon 5 meter per second square equals to 0.4 meter per second square on the planet. B. The radius of planet A is the half of radius of planet B. If the mass of A is ma, what must be mass of B so that value of G on the B is the half that of its value on A? Given. Answer given. RA equals to RB upon 2, GB equals to 1 upon 2 GA. MB is what? G equals to GM upon R square. Therefore, GA equals to GMA upon RA square and GB equals to GMB upon R square B. Therefore, GB upon GA equals to RA upon RB square into MB upon MA. Therefore, 1 upon 2 equals to 1 upon 2 square into MB upon MA. 1 upon 4 in bracket MB upon MA. MB upon MA equals to 4 upon 2. 2 1s are 2, 2 2s are 4 equals to 2. Therefore, MB equals to 2 MA. C. The mass and weight of an object on Earth are 5 kg and 49 Newton respectively. What will be their values on the moon? Assume that the acceleration due to gravity on the moon is 1/6 of that on Earth. Answer given. M is equal to 5 kg, W is equal to 49 Newton, GM equals to GE upon 6, M on the moon is what? W on the moon is what? The mass of the object on the moon equals the mass of the object on the earth is equal to 5 kg. W is equal to mg. Wm upon We equals to mgm upon mge equals to gm upon ge to 1 upon 6. Therefore, Wm is equal to We upon 6 equals to 49 Newton upon 6 equals to 8.167 Newton. Weight of the object on the moon. D. An object thrown vertically upward reaches a height of 50 meter. What was its initial velocity? How long will the object take to come back to the earth? Assume g equals to 10 meter per second square. Answer given. H is equal to 500 meter, g equals to 10 meter per second square, v equals to 0 meter per second, u equals to what? T for going up plus T for coming down equals what? As the object moves upward, v square equals to u square plus 2as equals to u square plus 2 minus g, h, a equals to minus g. Now v equals to 0 meter per second. U square is equal to 2gh equals to 2 into 10 meter per second square into 500 meter. u square is equal to 100 into 100 meter per second square. U equals to 100 meter per second initial velocity of the body. Also v is equal to u plus at equals to u minus gt. For v equals to 0 meter per second, u equals to gt. 100 meter per second equals to 10 meter per second square into t. T for going up is equal to 100 second. Now t for coming down equals to t for going up is equal to 10 second. T for going down plus t for coming up, 10 second plus 10 second is equal to 20 second. It will time take 20 second for the object to come back to the earth. E. A ball falls off a table and reaches the ground in 1 second, assuming g equals to 10 meter second square. Calculate its speed on reaching the ground and the height of the table. Answer. Given t equals to 1 second, g equals to 10 meter per second square, u equals to 0 meter per second, s equals to what, v equals to what. Equation. S is equal to ut plus 1 upon 2 gt square equals to 1 upon 2 gt square. For u equals to 0 meter per second. S equals to 1 upon 2 into 100 meter per second square into 1 second square is equal to 5 meter. The height of the table is equal to 5 meter. Equation second. V is equal to u plus at is equal to u plus gt. 0 meter per second plus 10 meter per second square into 1 second is equal to 10 meter per second. The velocity of the ball on reaching the ground is equal to 10 meter per second. F. The masses of the earth and moon are 6 into 10 raised to 24 kg and 7.4 into 10 raised to 22 kg respectively. The distance between them is 3.84 into 10 raised to 5 km. Calculate the gravitational force of attraction between the two. Answer. Given m1 is equal to 6 into 10 raised to 24 kg, m2 is equal to 7.4 into 10 raised to 22 kg, r is equal to 3.84 into 10 raised to 5, kilometer is equal to 3.84 into 10 raised to m meter, g is equal to 6.7 into 10 raised to minus 11 Newton meter per square kg minus square. F is equal to what? F is equal to gm1 m2 upon r square. जी ची m1 m2 ची आणि r स्क्वेअरची व्हॅल्यू पुट केलेली आहे इक्वल्स टू 6.7 इंटू 6 इंटू 7 इंटू 4 इंटू 10 रेज टू 35 अपॉन 3.84 इंटू 3.84 इंटू 10 रेज टू 16 न्यूटन इक्वल्स टू 2.017 into 10 raised to 20 Newton. This is the magnitude of the gravitational force between the earth and the moon. G. The mass of the earth is 6 into 10 raised to 24 kg. The distance between the earth and the sun is 1.5 into 10 raised to 11 meter. If the gravitational force between two is 3.5 into 10 raised to 22 Newton, what is the masses of the sun? Answer. Given m1 equals to 6 into 10 raised to 24 kg, r is equal to 1.5 into 10 raised to 11 meter, f is equal to 3.5 into 10 raised to 22 Newton, g is equal to 6.7 into 10 raised to minus 11 Newton meter square per kg minus square. M square is what? Formula. F is equal to gm1 into m2 upon r square. Therefore m2 is equal to fr square upon gm1. तर इथे मी त्याच्या सगळ्या व्हॅल्यू पुट केलेल्या आहेत 3.5 into 1.5 into 1.5 into 10 raised to 44 upon 6.6 into 6 into 10 raised to 13. So answer is 1.96 into 10 raised to 30 kg mass of the sun. तर इथे आपल्या सर्व एक्सरसाइजवरील प्रश्नांची उत्तरे झालेली आहेत. व्हिडिओ आवडला असेल तर चॅनलला प्लीज सबस्क्राईब करा, व्हिडिओ लाईक करा, शेअर करा. काही डाऊट असेल तर कमेंट सेक्शनमध्ये नक्की विचारा. भेटूया नेक्स्ट व्हिडिओमध्ये. थँक्यू फॉर वॉचिंग. बाय.